Hello guys, welcome into mathematical lesson. We are still continuing with these riders, but we are almost there. We are about to finish these lessons of the riders. So we will be doing the question 9 that is right here in front of the screen. 9.1. 9.1 says to us in the figure, the center of the circle is O. A, B, C, D, and E lies on the circle such that chord AB and chord DC are equal. Okay. What else are we having? Or are equal in length. And the angle AEB is equal to 39 degrees. So this one is equal to 39 degrees. Now, let us use the technique DRCPT. DRCPT. Okay. Now, where the D is the diameter, is there any diameter? No, there's no any diameter. We'll cancel D, we go for R, the radius. OA is the radius. OB is the radius. Therefore, OA is equals to OB radi. Therefore, now they forces the triangle ABO to be an isosceles triangle. Now, we can confidently say angle OAB is equals to angle OBA. Why? Because that is the base of an isosceles triangle or angle the opposite equal sides. We are also having OD as the radius, OC as the radius. Therefore, OD here is equals to OC. Now, that forces this angle to be equals to that angle, angles opposite equal sides, or base of an isosceles triangle. Then we don't have a tangent, therefore we cannot have that theorem that says a radius is perpendicular to the tangent. Now we are done with the R. Let's go for C, the cyclic quad. We don't have any cyclic quad. We go for P, parallel lines. We don't have any parallel lines. We don't have any tangent as well. Now, we can now move into the problems and see how we can answer the questions that we are required to answer. Now, determine the size of O1, angle O1. Now, they didn't tell you determine the size of O1 given reasons, but you must always provide the size accompanied by the reason. Now, O1 is there and O1 at the center. Now, remember the angle at the center, we say it is subtended by that arc. Now, there's also this angle at the circumference that is subtended by the same arc AB. So this angle at the center will be 2 times that angle at the circumference. Now, this angle will be equals to 78 degrees, reason being angle at the center is 2 times angle at the circumference, right? Yes, now you have got your beautiful mark for the statement and a beautiful mark for the reasoning. Let us go for 9.1.2. They say to us, determine the size of angle O2. O2 is that one that is that side. So remember, we have that theorem that says, okay, this is our triangle. This is another triangle such that there's a chord here that is equals to that chord. And there's angle that is equal to that one. Reason being, equal chords subtend equal angles at the circumference. Okay. We have something like this also. Yeah. This chord is equal to that one. This angle is equal to that angle. Equal chords subtend equal angles at the center. Now, we have something like this. This. Okay. We also have something like that. Okay. These chords are equal. Now you can say this angle is equal to that angle because another angle is at the center, the other one is at the circumference. So both angles should be at either at the center or at the circumference. This one, both angles are at the center. This one, both angles are on the circumference. So only these two angles where only these two scenarios where you can say equal chords subtend equal angles. So angle O2 is going to be equal to angle O1 is equal to 78 degrees. Then you say equal chords subtends equal angles. So we're going to say equal chords subtends equal angles. Then you are done. You have your beautiful mark for the statement, your beautiful mark for the reasoning. Then now you have very beautiful 4 marks inside the pocket. I hope everything makes sense to you guys. Let us go to the next question, 9.1. They say to us, in the diagram, S is the center of the circle, PQRT, and then PT is the diameter of this circle. Angle RST is equals to x minus 8 degrees, and PQR is equal to 2x minus 40 degrees. Now, we will do the technique DRCPT as usual, the Dr. Cape Town technique, which is the diameter. Yes, there is a diameter there, but now we don't have that angle that is subtended by that diameter like that. So we can't have that angle that we will say it is a right angle there. We will proceed to the R, the radius. Yes, there is this radius, but we don't have that line that forms this triangle to be an isosceles triangle. Okay. Also here we don't have that line that joins P and R to form an isosceles triangle PRS. Okay, we will pass that. C, cyclic quad. We don't have any cyclic quad because someone maybe might say this is a cyclic quad because it has 4 corners, but the mistake that you will be doing it is that this fourth vertex of this quadrilateral, it is not on the circumference of the circle. Therefore, PQRS is not a cyclic quad. The parallel lines, we do not have any parallel lines. Okay, then we go for the T, which is the tangent. We don't have any tangent here on the question. Now, let us go to the questions and see what we can do. Now, here, they say to us, determine the value of x giving the reasons, right? Yes, they didn't state that you need to give the reasons, but you always must give the reasons in everything that you do here in Euclidean geometry. So now you will say x minus 8, which is this one here on the at the center. This angle, okay, let us do this actually. Let us do this. Okay, this is my center. Angle at the center is 2 times angle at the circumference, right? Okay, now let us stretch that angle at the center. We stretch it. Now, still, angle at the center is 2 times angle at the circumference. Let us stretch it again. Let us stretch it again. Now it is straight. It is a straight line. It is 180 degrees. This is the diameter. It forces that to be 90. This is 2 times that one, right? Yes. Now, let us continue with the direction of ours. Now, we were stretching this angle to those 2 directions. We also stretched this one into those 2 directions. Now, let us continue bend. Now, let us bend our angle to be more than 180 degrees. This is our center. Now, angle at the center is 2 times angle at the circumference. Even in this scenario, this angle is 2 times that angle at the circumference. That is what we are going to do here in this question. So look, we are having that angle at the center. It is going to be 2 times angle at the circumference. Beautiful, eh? Nice. Now, let me erase this just to have some enough space to write on. Now, we're going to say angle at the center, which is 8 minus x degrees plus, this is the straight line, 180 degrees, is equals to 2 times angle at the center, at the circumference. What is the angle at the circumference? It is 2x minus 40 degrees. What is the reason? This is just the statement. The reason is angle at the center is 2 times angle at the circumference, right? Yes. Now, x minus 8 degrees plus 180 degrees is equals to 4x minus 80 degrees. Now, we will have, I take this x into the right-hand side. Now I will have 4x minus x gives me 3x. And then I will have minus 8 plus 180 degrees plus 80. I get 252 degrees. I divide by 3. I divide by 3. Now my x is equal to 84 degrees. 84 degrees. Then you are done. And now you have your beautiful 4 marks inside the pocket. I hope that made sense to you guys. It was a very beautiful question, eh? Now let's proceed to the next question, 9.3. 9.3 says to us, in the diagram, O is the center of this circle. Chord AC is perpendicular to the radius OD. Theorem 1. A line drawn from the center perpendicular to that chord bisects the chord. Therefore, AB is equal to BC. That is theorem 1. OB is 2x units. OB, this is OB, this is 2x units, this part here. Okay, and AC is 8 units, meaning AB is 4x, BC is also 4x, so that when we add the two, will give us 8. So this is a bisector. It divides that into 2 equal parts. Now, how are we going to show that the length of BD is equal to 2x times 5, the square root of 5 minus 1. Now, the thing that we will do, we will say AB is equals to BC. Why do we say that? Because the line drawn from the center of the circle perpendicular to chord bisects the chord. This is theorem 1, right? That is the first thing that you will do. Then you get the mark for the statement, you get the mark for the reason, right? Now, you can use Pythagoras theorem because you have this, you want the radius, okay? OA squared is equals to OB squared plus AB squared. Why? This is the Pythagoras theorem. What is OA? OA is the one that we are looking for. What is OB? It is 2x squared. What is AB? It is 4x squared. This will give me 4x squared plus 16x squared, right? Now, Everything here gives me 20x squared. That is OA, right? Now, that is OA squared. If we want OA, we will square root both sides. Now, OA will be, what is the square root of 20? The square root of 20 is 2 root 5. The square root of x squared is just x. Now, OA is 2 square root 5x. This is the radius, this is the radius, this is also the radius. So we are having 2 square root 5x, 2 square root 5x. Also with OD, we have 2 square root 5 and x. Now, in order for us to find BD, it is OD minus OB. But before you go there, you will say OD is equals to OA. Why? They are both radii. Then now, what is OG? OG is equal to OA. It will be 2 the square root of 5x minus OB. OB, we are given it as 2x, right? Now, we can take 2x as the factor. We say 2x inside the bracket. We took 2x here. We are left with square root 5 minus we took 2x here. We are left with 1. Now, we have shown that BD is equals to this thing units. Then you will get your beautiful 5 marks inside the pocket. I hope everything made sense to everyone here. Now, let us proceed to the next questions here. Question 10. Question 10, okay, here it is. Question 10 says to us, in the diagram below, O is the center of the circle and PTSR is exactly quadrilateral. Now, we are going to go, since this is the proof, we don't have to do the DRCPT, the proof. You need to know everything that you have to do before you can answer it. So now, we have to prove that P and S are supplementary. Now, we will join this one and this one, right? Because we are going to prove these ones. If we were going to prove these ones, we were going to join these ones. Now, you label your O. We want to have O1 and O2, right? Now, let us go. We want to show that angle P and angle S is equal to 180 degrees, right? Now, angle O1 is equals to 2S. This angle at the center is 2 times angle at the circumference. Angle at the center theorem. Now, angle O2 in the center, 2 times angle circumference, is equals to 2 times P. What is the reason? Angle at the center is 2 times angle at the circumference. Now we have this thing. Now, angle O1 plus angle O2, which is this part plus this part. That gives me 360 degrees, not 380, but 360 degrees. That is angle around a point or a revolution angle. Revolution angle. Now, what is O1? O1, we said it is equal to 2S. What is O2? We said that is equals to 2P is equals to 360, oh, not 80, 360 degrees. You now can take on the left-hand side, you take 2 as a common factor. Now angle S plus angle P is equals to 360 degrees. You divide by 2 on the both sides. You are left with the sum S plus P here, right? now is equals to 360 degrees divided by 2, which gives us 180 degrees. Now we have proved that the sum of S and P is equals to 180 degrees. There, it doesn't matter if the P comes first or the S comes first, like P plus S is equals to S plus P, because the sum is commutative. Those who will be taking maths in the university will know what does the commutative property mean. Now let us go to the next one at 10.2. Let us have a look on 10.2. So 10.2 says to us, in the figure, let us see the figure. Let us see the figure. Okay. Excuse me. Let us see the figure. QS, this is QS, and PR are the diameters, okay, of the circle with the center O such that PQ is parallel to RS. PS is produced to T, okay. Okay. N is a point on the circle such that Q1 is equals to Q2. These angles are equal here, right? SN is drawn. Now, RS intersect QN at M here. S1 is 48 degrees. Now, using DRCPT, the diameter, we know that this is the diameter. Now this diameter subtends this angle. This angle is 90 degrees. And this is the diameter. It subtends this angle. This angle here is 90 degrees, right? Yes. Then R, this OR, OS are the diameter, therefore angle R and S3 are equal. Angles opposite equal side. And angle Q1 is equal to angle P, angle opposite equal side. And OPS is equal to S4, angle opposite equal sides. And again, angle R is equal to Q1, angles in the same segment, and angle S3 is equal to angle QPO, angles in the same segment. That is the R. The C cyclic quad, this is the cyclic quad. Therefore, this angle is the exterior angle of a cyclic quad will be equal to that angle. That is the interior opposite angle of a cyclic quad. And then this angle and this angle are supplementary, and that one and this one are supplementary. Then P parallel lines, this angle is equal to that angle, reason being alternating angles, because P is parallel to SR, and this one are equal alternating angles because PQ is parallel to SR. Then the T, we don't have any tangent. Now let us jump into the problems and see what we can cook there. Here we are required to find the size of Q1. Now this is what we can do. We said this is the cyclic quadrilateral. Now this angle is equal to that angle, right? So we are going to say whole of Q is equals to that 48 degrees here. Why? Because that is the exterior angle of a cyclic quad, right? Beautiful, eh? Nice. Now let us go now back to the statement that we were given. We were given that Q1 is equals to Q2. Therefore, we can just divide Q into two equal parts, right? Now, when we divide this into two equal parts, it will be 48 divided by 2. 48 divided by 2, I will get Q1 is equals to Q divided by 2, which is equals to 48 degrees divided by 2. I now get 24 degrees. Now Q1 is equals to Q2. That is given. Yes. Next question, we are required to find the size of R. R is equals to Q1. We have mentioned that when we're using the RCPT, because these are the angles in the same segment, that is equals to 24 degrees angles in the same segment, right? Fine. Now let us go for the next one. We are required to find the size of angle M1. M1, where is M1? This is M1 here. What are we going to do now in order for us to prove M1, or to find M1? Now, we said this line, no, in fact, we didn't say. We were given that this line is parallel to this line. Therefore, this angle is equal to that angle corresponding angles. Therefore, M1 is equal to angle Q, the whole of Q. It is now 48 degrees. Corresponding angles are equal. Why? Because PQ is parallel to RS. Then you are done. You have your 6 marks inside a pocket. Now, let us go to 10.2.2. Prove that ST is the tangent to the circle MNS. To this circle, that ST can be a tangent. Now, what is this? This is 48. Now, we'll just say M1 is equals to S1. We know M1 is 48. We know that S1 is 48. We were given so clearly you can see that. Now you can just say ST is a tangent to MNS. That is the converse of the turn chord theorem. Then you have your beautiful 14 marks inside the pocket. Otherwise, guys, let us end here for this lesson. I hope everything made sense to you guys, and you enjoyed the lesson. We'll meet again in the next lesson. Thank you, guys.